last example in 8.9, wow, we have learned so much about quadratics in this chapter. You've done an amazing job, and I'm extremely proud of you. Example 5 is just very simply choosing your method of solving. I provided you 5 strategies, and these are the ones I showed you. I said you could graph, right? We did graphing. We said, hey, you could factor. If it's factorable, you can factor. So I should say factoring, not factorable. And then square root property. That only works sometimes, you know, only if there's no bx term. You can complete the square. I just draw, that's a square. Looks like a rectangle, but it's a square. Or you could do the quadratic formula. Okay, those are your 5 strategies. Only these 2 that I have an asterisk, it doesn't matter the situation, you can always do those 2 if you want to. You can always complete the square to find your answers. You can always use the quadratic formula to find your answer. The other 3 depend. They just depend, okay? Now, you could, I'm just going to do one of these, and I'm going to leave the rest of them for you to find the answer using your personal strategy. If you want to use all quadratic formula, then use all quadratic formula. I really don't care, okay? I'm going to start right here. This is the one Mrs. Thompson's going to do right here is x squared plus 7x plus 6, and I'm just going to go through each one and just show you. I'm not going to show you the graphing. You can put that into your y equals, set your window, use your table or use your trace to find the answers, okay? Now, I am going to show you some of the other ones, the other strategies. Now, this is factorable, believe it or not. When I try factoring, when I see a coefficient of 1 in front of my x squared term. If it has any other number other than 1 in front of x squared, I do not attempt factoring ever. That's just me. It's laziness, probably more than anything. It's not laziness, efficiency. It's not efficient use of my time. I can find another way to find my answer faster. Because remember, not all quadratics are factorable. These are easy to test. Remember, all you have to do on a situation like this is ask yourself this question. What are factors of 6 that add up to be 7? What are factors of 6 that add up to be 7? Yeah, 6 and 1, both positive. So then all I have to do to solve it is set each one equal to 0. And then I'll just solve for x in each one. And my first answer, I'll get negative 6. And my second answer, I'll get negative 1. Now, if you graphed it, go ahead and graph it if you want to. Just put me on pause and use your y equals. And, you know, set your scale to 1 when you do the x scale and the y scale. Set it equal to 1. And then set your minimum and maximums. When you graph it, they're going to crisscross at negative 6 and negative 1. Exactly. So you could have graphed it on your graphing utility and gone, oh, it crosses exactly at these 2 numbers. Would have been no problem for you. It's also factorable. I just showed you that. Square root property is not an option here. Okay? Not an option because this trinomial has a bx term. Square root property only works on binomials that have the squared variable and a constant number and no bx term. So can't use the square root property. Now completing the square, that one I can do. I'll probably end up going right over the top of this one. So if you've got notebook paper, just go ahead and just maybe write this one down on notebook paper because I'm going to mark through it, okay? So you're going to use it. You're still going to do it, but I need the space. So x squared plus 7x. I'm going to move my 6 to the other side. I'm going to subtract 6 from each side. And then I need to create a perfect square trinomial on the left. So I need to take half of 7, or divide 7 by 2. Just leave it as 7 over 2. And then square 7, which is 49, and square the 2, which is 4. So I'm going to add 49 fourths to each side. Okay? Now when I take the square root, or factor it, I'm not ready to take square root of anything, and when I factor it, I'm going to have x plus, and then 49/4, take square root of 49, that's 7, square root of 4 is 2. And then I need to add 49/4 and -6 together. So I'm going to rename -6 as, let's do -24/4. That's -6. And then we're going to add 49/4 to it. Now, 49 and -24 looks like 25/4. Okay, now we're ready to take the square root of each side. I'll have x plus 7/2 equals positive or negative, and square root of 25, remember, is 5, square root of 4 is 2. So here are my two equations. X plus 7/2 is equal to positive 5/2. X plus 7/2 is equal to negative 5/2. Okay, and then let's solve. Let's take away 7/2 and see what we get. All right, so I've got 5/2 minus 7/2. That's -2/2, which is -1. See, I got that answer as well. And then I take away 7/2, and I've got -5/2 minus 7/2 is -12/2, which is -6. See? It doesn't matter what my strategy is. I'm going to get the same answer regardless of the strategy I choose. So here I factored. Here I completed the square. Now let's do the last strategy. Could have graphed it. I didn't show you that on the board. You can do that in your calculator. Let's try the quadratic formula. So I'm going to go to b squared minus 4ac and do that first. So b squared, that would be 7 squared minus 4 times 1 times 6. Okay? So this is where you need your calculator. Carefully plug it in. Go ahead and put parentheses around the 7. Do 7 squared minus 4 times 1 times 6. And I got exactly 25. Now, because my discriminant is positive, that means, yes, there are two answers. So I'm going to plug into negative b plus or minus the square root of b squared minus 4ac over 2a. And the opposite of b. B is 7, so the opposite of that is -7. Plus or minus the square root of 25 over 2a. A is 1. 2 times 1 is 2. So here are my two equations. -7 plus or minus the square root of 5 over 2. So we're going to do -7 plus 5 over 2. And then we're going to do -7 minus 5 over 2. So we'll start with the numerator. -7 plus 5. That's -2. And -2 divided by +2 is -1. Look, -1, -1, -1. Wow. -7 minus 5 is -12. -12 over 2 is -6. Look, here, 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 here. So let me ask you a question. Does it matter what strategy I utilize? Clearly not. I could have graphed, factored, completed the square, or done the quadratic formula, and all four of them would have told me that that parabola crosses at -6, -1 on the x-axis. So it doesn't matter your strategy. You choose your method. What looks easier to you? It is up to you. I don't care. It really doesn't bother me either way. Okay? If you're like, Mrs. Thompson, I just want to do it one way all the time, I'm doing quadratic formula, knock yourself out. Okay? It really doesn't matter. All right, I'm leaving the rest of these. Do this one. Pick a strategy. Do that one. Pick a strategy. Do this one. And even though I marked through that one, I want you to do that too. So I'm going to give you 3 points extra credit, 1 for each of these. If you can tell me what the x-intercepts are, what are the zeros for those 3 remaining, you choose your strategy. Good luck with that. Bring your questions to class tomorrow.